Number 7 here is another graphing calculator question. As I said in the last video, it would be nice if I could use my calculator and have it show up on the screen, but it's just not really possible with what we're working with. So number 7, open box problem. We've done lots of these. Actually, I probably need it to be a little bit bigger. So it tells me 21 by 56 inches. So what I'm going to do is draw a big guy like this. This will be my 56. This will be my 21. I cut out corners, so cut out corners like shown here. And what I can do is I'm going to fold it up along this dotted line and make a box that does not have a top. So that's what it would. That's kind of the drawing that I'm looking for part A. You could also give me a 3D version of this, like this, and I need to kind of show a little bit more with what these inside dotted lines are going to be. So if I look at that dotted line, the full length here to here is 56. So when I cut this corner out, I take this x, so that length away from the 56, and this length away from the 56. So this in here is going to be 56 minus 2x. If I were to label that on my 3D version, it would be this guy down here, because that would be the same for this guy. Then, similarly, this is going to be 21 minus 2x. So I can label this guy as 21 minus 2x. And then when I fold it up, we've talked about this a lot, that height becomes x. So either one of these pictures would be good for part A. You would want to have all these pieces labeled that I have labeled. So, next one. Find an equation of the volume of the box in terms of x, the square size cut out of each corner. So, volume is length times width times height. So all I have to do is multiply each of those sides. V of x is equal to, I just want to use parentheses to make sure that I write everything correctly and that the order of operations happens right. So I write 56 minus 2x times 21 minus 2x times x. So, next thing I want to think about is, so I got this done, got that done. Now we're going to do C. What's the domain of this in the context of the problem? Well, I could actually plug any value of x into this volume equation and it would work. But I need to think practically in terms of this box that we're making. First off, it would be impossible to have a negative cut length. Also, if I have a cut length of 0, I'm not going to get a box. So, when I'm talking about my domain, I'll write here, domain, it's going to start at 0. Then, the side that's going to limit me is going to be this 21 side right here. I only have enough, half of 21 is equal to 10.5. And if I go beyond that 10.5, like say I made an 11-inch cut, is it inches? Yeah. Then I would be, like, from the bottom, I would cut 11 inches. And then I wouldn't have enough to cut out a corner from this side. So 10.5 is kind of the limit on how far I can go when I'm making this cut if I want to get a box. I could make a cut length of 10, it would just be really tall. It wouldn't have a high volume. So my domain is 0 to 10.5. I'm going to erase this picture, so make sure you're good with it. So the reason we talk about domain is because it helps us find a window. If you're really confused about how to find a window, you should go back and watch the video on number 6, because I talked for quite a bit in there about different things that show up in the calculator. But with this one, I go to my table in my calculator, so I hit second graph, and I plug some numbers in. The numbers that I plugged in were 4, 5, and 6. I got numbers that were kind of close to 2,500. So what that tells me is that, so this is my x, this is my y, in the table in my calculator. So what that tells me is that I want to round up generously for my y window. So I'm going to go to my window, I'm going to make my x min equal to 0, my x max equal to 10.5. That comes directly from the domain. It's always going to be the domain there. My y min, well, contextually, think about it. I'm not going to have a volume smaller than 0. So I start at 0. And then, so my y max is kind of the most difficult part of this to get right. I got 2,500 here, and I'm going to use that as a clue for how big I want to make y. I'm going to take it and round up generously and make my y max equal to 3,000. If I hit graph with that, it should show up pretty well. And I hit graph, and it does. So I get it in the first try. So now let me pause for a moment, make sure you have that info down. So when I graph this, this is what my graph shows up like. It almost looks like a parabola, but it's kind of like pushed off to the left a little bit, like a piece of jello or something like that. I don't know. Anyway, so this next question D asks, what will give me a volume of 2,000? So what I'm going to do is go to my y equals screen. I currently have y1 equal to this. So that's my y1. I go to y2 and set it equal to 2,000. I do that, I get 2,000, and now I'm going to go back to my graph. What happens is I get a new line that goes like this. So that represents the height of 2,000, which is a volume of 2,000. So what I can do is use the calculator to calculate this intersect right here and right here. And I do want to make sure I give both of them. So I'm going to go second calc to intersect. I'm going to go close to the one on the left. I'm going to make sure I'm on the right line. So I hit enter for y1. It says y2. I hit enter. Now it asks me for a guess, and I hit enter. And I get that this guy is at x equal to 2.418, but it rounds up to a 9. I go and do the same thing for this one, and I'm not going to talk my way through it, but I also do a cut size of 7.144 and get the same volume. I get it once on the way up and once on the way down. You do want to make sure you give me both of those. Last thing I'm going to do, so I got D taken care of, I got to answer E. It says, what's cut size will maximize the volume? So I go to my second trace button, my second calc, and I choose max, and then I go left bound, so I'm going to go left of it, I'm going to go right bound, and I'm hitting enter at each of these, so I hit enter again. Now I go and make a guess that's close to here, I hit enter, and it gives me a value, an x value equal to 4.66. I guess I could round up like that. You could also write 4.66 with the line over top of it if that's what your calculator gave you. That's the corner cut size, so that's the answer to this question right here. And the volume is my y. My y in this case is 2540.741. So that's the answer to this. Remember, I want 3 decimals to make sure that I get you in good habits. And that should be that.